Okay, thank you, Destiny. This workshop is on an introduction to artificial intelligence with custom vision. So, assuming no prior knowledge of AI, it's basically machines or computers that can make intuitive decisions based upon some set of training it undergoes. So, from Rick Paraza from Microsoft, he mentioned that AI is computers doing things that we would normally think of as intelligent in humans. This implies that with with traditional programming, right? Um, Computers follow a pre-built, a predefined step-by-step procedure in order to give output. But with artificial intelligence, it gives computers the capability to make uninformed decisions, just like humans usually do. So here are a few definitions, key terms I'll be interchanging using the course of this workshop. Um, you don't necessarily have to claim or know them per se, just have an appreciation so that when I mention one word, it won't be as vague. So the first one, I already said, artificial intelligence is a branch of computer science whose main aim is to create machines or systems that can meticulously mimic human behavior. Machine learning is a subset of artificial intelligence that teaches a system to identify patterns in data, thereby having the capability to make inferences and base decision on past experience. Like I mentioned before, AI involves computers trying to make uninformed decisions, just as humans do, by making inferences on the data that should initially fed to it. Custom vision, again, is a subdomain of AI that deals with visual processing, making inferences on pictures or images or things that it can see. Well, computers seeing things basically. And what we're going to be looking at today specifically is custom vision, which is essentially a cognitive service offered by Microsoft Azure. Azure is a cloud computing service offered by Microsoft, which offers computing services over the cloud. So Azure Custom Vision is an image recognition service that lets you build, deploy, and improve your image identifier models. We'll do a practical example on this, but let's try and see more on how exactly machine learning models get inputs and actually make decisions that are seemingly intelligent. Okay, so this is an abstract example of a human being. We take in sensory inputs. We see things, we hear things, we maybe touch things, right? And we take this as input. Our model, being the brain, processes this input. Let's say you you put your hand on a stove that was recently on and it's burning hot. The sensory input is your hand feeling this heat, your brain processes that, and then you give out some sort of behavior as a response to stimuli. The same with robots, machines, or computers, right? They take in some form of data, and then the machine learning model is what processes this particular information and gives some sort of solution based on the model that had been trained. So let's give a practical example in the domain of um, classification machine learning, right? Per se, in the field or domain of medicine, they want to make a machine that can identify cancerous cells in a human being. What happens is this: you take in or you give input to a computer, right? And you actually identify it based on, you give it a few inputs as read, identifying the damaged or cancerous cells, and then the green as the healthy cells. Use a machine learning algorithm to teach the model. The model is the cloud labeled deceased, right? Then after you teach it, you give it some form of data, uncategorized, unclassified, right? Then, based on its past experiences or inferences, it actually categorizes it as either diseased or healthy. So from what you can see, the model isn't exactly perfect because as you can see, there's one green cell that's identified as cancerous whilst it's healthy, and then there's one that's red and categorized under healthy. This implies that machine learning models cannot be 100% precise or accurate. You can't exactly base your main conclusive decision on it, but it's good enough to some extent. So yeah. So there are types of machine learning models based upon different criteria. So there's classification. This assigns a category to a particular value. From the example we're going to be using today, it's taking some sort of input, right? Let's say, for instance, you have eating utensils or cutlery. You divide it based upon, it being a spoon or it being a fork, right? Those are discrete values. It's either it's a spoon or it's not a spoon. That's classification, basically. Regression analysis works in making predictions about, well, numerical values, basically. Let's say, for instance, that chart shows the probability of it raining or being cold on a particular day, right? And it spans over a month. If you use a machine learning model that uses regression analysis, it can actually make a forecast of whether or not it might or might not rain in future. That's basically regression. Anomaly based, I'll give an example under the under computer science domain. Antivirus softwares use anomaly machine learning models in being able to identify malware. Within the software, they give a database of the normal or what's expected of a particular computer system to, like, how it's supposed to operate, right? Based off of that database, if something deviates from that particular normal, then it implies that there's an anomaly and it's flagged as malware. So yeah, that's basically to do with anomaly. Reinforcement learning, it's basically predicting which next step could be done. It's fairly similar to regression to some extent, because as you can see from that particular diagram, that's a chessboard. You can actually play chess with the computer. Some of you are chess fanatics, have done this before, I'm sure. It uses a machine learning models to actually predict the best next step to a particular situation. That's reinforcement learning. And then clustering, it gives a particular subset or cluster of data based on some particular traits or characteristics of people. So this type of machine learning model is used in it's used in making project recommendations. Netflix uses clustering algorithms because you can actually it can actually predict that this particular age group, which is one cluster, likes these types of movies. So it can actually give recommendations as to which movies you might enjoy watching based on the particular cluster, right? So all of these are machine learning models, and all of the examples I gave are all enabled by machine learning. So what's the difference between machine learning, artificial intelligence? Sorry?
Hello. Before you move on, I want to ask something. In reinforcement learning, is it correct to say it works in the same way as how you train a child? If they do wrong, you punish them. If they do right, you reward them. Is that accurate?
Yeah, exactly. That's actually an analogy that's used by most people. Um, in the instance of a chess game, right? It makes a wrong move, it gets beaten by the human, right? It won't make that exact same mistake again. So yeah, that's reinforcement learning.
Okay, thank you for the clarification.
That's okay. Okay. As I was saying, artificial intelligence, machine learning, deep learning can actually be used interchangeably by, well, some people do that, but here's the difference. AI, like I mentioned, is anything and everything that enables computer to make uninformed decisions or intelligent decisions as humans do, basically. But actually, no. Machine learning, neural networks, and deep learning are all subsets of artificial intelligence that use different algorithms to be able to give decisions. So in all these domains, there is some appreciation and need for mathematics and statistics, well, statistics basically, and discrete mathematics and some bit of number theory to be able to understand how the machine learning models work. But as an alternative from what we're going to be doing today, we're going to be using what is known as custom vision. Custom vision are pre-built training models made by Microsoft for the purposes of being able to give the same output without actually the need to write code or anything. So yeah, those are basically the differences in a nutshell. Today we're focusing on classification algorithms because those are what are used for making categories in custom vision. Okay, so I'm going to show you a short video on Microsoft Learn, which is essentially a platform made by Microsoft for students to be able to learn um, different Microsoft technologies interactively. So I'm going to stop sharing my screen. I'm going to share my browser. Just a minute. Is my browser visible? Marian, yes. I really do hope that you are. Sorry?
Yes,
Yes, it's
visible.
Yes, we can see your browser. You can go ahead.
Could look out for our
Hello, Blessing. There's no sound though.
Okay, so there's an application called Seeing AI, as you saw in the video. I hope it played well on your side. Hopefully the network wasn't that bad. Seeing AI is basically a solution made by Microsoft to work on all problems associated with computer vision. So these are some of the subdomains. I'll just run through them. There is image classification, being able to identify a particular um, a particular object and classifying it. There's object detection, semantic segmentation, image analysis, face detection, analysis, and recognition, optical character recognition. So the link is in the PowerPoint slides. I'll give you the PPT so that you can actually look for this in detail. But yeah, that's the basic gist of it. Okay, so like I said, Custom Vision is a web-based application made by Microsoft to identify image and classify them based upon what they are exactly. So it's done in 3 basic steps. The first one being uploading your images as labeled. Like you label the images based on what they are. Then you train your model. Then you make an evaluation as to whether the input you give it, the results is accurate, right? So I think from now on we can do a practical example. I hope the network won't be as bad. Okay, so the first step in deploying your machine learning model on Custom Vision is actually creating an instance or resource on Microsoft Azure. You can get, I think, about 20 of Microsoft Azure Cloud Services for free if you sign in on the platform using your student ID. So that is definitely worth checking out. Sorry. See. Okay, so basically what you do is you create an instance or resource on Microsoft Azure by going to create a resource. On the top left, I already made my resource, so I'll just walk you through how it's done for Custom Vision. Okay, you create. Okay, so what we want our model to do on Custom Vision is to be able to train it, right? Give it some form of input for it to be able to train, and then we make predictions based off of that, which is the test data. So on create options, you select both. Then subscriptions, since you log in, as you can see from the top right, I signed into Microsoft Azure using my student email from HIT. I select Azure for Students. resource group, you just write custom vision like this or something totally random. It's basically up to you. On the region, here's what happens. Azure has servers around the world. So if you want a more efficient machine learning model, it means that you have to choose a region that's closer to where you stay so that the connection won't be as far-fetched as, you know what I mean. So yeah, you choose. I'm not really sure which area is closest to Africa here, but yeah, just choose one of those. Anyone will do, but the model will be faster if you choose a region that's closer. On the name here, give it a unique name. You can maybe say custom vision, your name in front. Training pricing tiers, it's free because you are signing in with the student account. All these services are paid for, as you can see on this on this web page, and it's way expensive. But from the free services offered by Microsoft, it's actually good enough to be able to start up and begin training. So once you fill in all that, you just click on review and create, then everything is all set. After you're done, you go to custom vision here. Then let me try opening a new tab and restarting. See if I can start from scratch and show you guys how it's done exactly. Okay, so you start new project. I already started the project in anticipation that my network would have would have bailed out on me. But yeah, you start a new project right here. You give your project a name. In a particular instance, we chose dog classification. And then give it a description if you like. If you're supposed to sign in with an email address, so use the same one you used for Microsoft Azure so that it synchronizes the two and you get your subscription right here. So yeah, choose that. Choose the project type. We're doing classification. Classification type is multi-class because you're only tagging. We're giving one tag for one image. So yeah, leave everything else on default and create project. It's going to take a bit of time. Yeah. So as you can see, the interface is very intuitive. It's easy to use. What you do is click on add image. So, okay, I'm sorry, I hadn't mentioned this before. You need particular images of the things you want to create a classification on. So in our example, I'll be using dogs. As you can see, these are different breeds. There's the American Staffordshire, there's the Beagle, the German Wirehead, but we won't be using all of these for the sake of time. We'll just try out an example that works really quick. So let's say I choose maybe 4 of these for the Beagle. Open. I give them a tag, right? A unique tag. Then I upload these. It might take a bit of time based on network, but I hope it won't take that long. So we repeat the same process for the other breeds of dogs. This is done. Maybe give it another set of images. A Shoki, maybe 5. I'll show you later why it's an advantage to input a lot of images into your machine learning model rather than just a few. This is for the sake of the example, so I'm doing it a bit quick, but you can actually upload all of them. This might take a bit of time. I already uploaded most of them on this instance, but as you can see, it's still training and it might take a bit of time. I'm not sure when it's going to end. Okay, these are uploaded, right? We input 2 different breeds of dogs, right? After we're done with this, you just click on train. Leave these on default, quick training, and you start the training. Can't be training. Make sure you have at least 2 tags and 5 images for every tag. Okay, so we have 4 here. Let's add. So it's my mistake. I'm sorry. They give a minimum of 5, unfortunately. So let's add 1 more on the buggles. Okay, I think we can start now. Awesome, it's loading. So let's leave it to load for a bit and we can backtrack on the presentation as it loads. I hope it won't take that long. Okay, probability and AI. No model is perfect. The probability indicates how correct the model believes its answer is. So the first thing you have to understand is all models represent a closed universe. This implies that if you're doing a classification for dogs, right, and you give it maybe 5, 6, 7 different breeds, what it knows, what it appreciates, this machine learning model, are the dogs, right? It's the entire universe. It's encompassed only by dogs. If you give it a picture of a car and you try to classify or categorize that, it will try its best to make it one of the dog breeds as you had given it only dogs as your training model, right? So yeah, that's what it means by it's a closed universe. It can only process the things that are within the model. And what I said, all models will make mistakes and not be 100%. A probability score above 80% is commonly acceptable. This basically implies that it won't exactly be perfect as you might expect, but 80% is acceptable. Like you saw in the previous example with the diseased cells, right? Based on whether they're healthy or they're cancerous, some might be flagged as healthy when they're not, because it can't exactly be accurate. How do you make it accurate? The third point suggests that use different angles, settings, and lightings. And the more images, like I mentioned before, the more images you give to the model, right? It means the higher the probability of it giving you a more accurate result. So yeah. Performing a prediction. After the model is trained, you make the predictions to determine which classification matches the image. So let's go and try and check if the model is done with the training. If it's done, then we can try making predictions based off of that. Okay, so they're taking a bit of time to train. Maybe we can move forward to questions as we wait for this to finish. Is there anyone with a question? Let me check in the chats. You can actually type out your question or just unmute yourself and ask. It's still cool. Thank you, Destiny, for the heads up. I was looking at the chats. Okay, so this is done. And we've trained the model. So let's do a quick test. We trained it to give the only two breeds, right? There was the Bago and there was the Shoki. So let's use the images we hadn't used. These were the training images. Let's use the testing images for the example. Give this one, open. It analyzes. It might take a bit of time. You see? Probability is 99, that's the Bago, and it's 0% that it's the other breed. So yeah, this is basically custom vision, making predictions and actually uninformed decisions as a human being would. Let's try out another example. This one. As you can see, the testing images are not as clear. They try to give out different lighting, different backgrounds so that it confuses the model, but still it gives an accurate result. 99%, the probability that it's a Shoki is 99.8, and that's the Bago is 0.1. So yeah, it's basically accurate, as you can see. That's all to do with, we would have done more examples, but then for the sake of examples, I'm sure this was basically it. So anyone with questions as far as custom vision is concerned before we conclude the session? Before we leave the browser.
No questions, but may you share the recordings?
Okay, I will definitely. Okay, so let's conclude this. Oh, no questions. Go, I'll just leave about maybe 2 more minutes for people to ask. So what's next? We did classification, right? You can try out object detection. It's also offered by Custom Vision. It's relatively the same as classification, But with object detection, right, it's used, let me give a practical example. In developed countries, there are robots that can actually make predictions on the traffic on a particular road, or which objects are traveling within the road. So it's integrated on the CCTV cameras, and yeah, that's basically how it works. Also check out custom models with TensorFlow. It's a framework for AI. So yeah, it's definitely worth checking out as well. There are a few Microsoft Learn modules that teach custom vision, specifically artificial intelligence, machine learning, and their certifications. Oh, here's another interesting thing. Microsoft now offers all students free certifications for fundamental certificates. So you can be certified on Microsoft Azure Fundamentals or Office 365 or any other Microsoft technology available on Microsoft Learn. You just have to sign in with your student email, and yeah, you're all set. If you want to hard code these machine learning models, if you are into AI, you can check out my GitHub repository. I shared the link on the PowerPoint as well. It has machine learning algorithms and deep learning algorithms written in Python. So you might want to check that out as well. So yeah, questions before we conclude all of this? It's basically done. If you have time, there's this workshop survey. Just a few questions. If you are free to answer them, it will only take you maybe like 1 or 2 minutes. It's based on this particular workshop and my performance in general. So yeah, thank you so much for joining. I hope it wasn't too long, and I hope I didn't overwhelm you with too much information. Like I said, I'm Blessing. I'm an Alpha Microsoft Learn Student Ambassador, student at HIT. If you'd like to reach out, you can email, send a Twitter message, or LinkedIn. And also, I'd like to thank Destiny. Destiny is a beta student ambassador from Nigeria. Is my peer mentor for my alpha to beta advancement in the Microsoft Learn Student Ambassadors program. And also Clint, I'm succeeding in the program at HIT. So thank you so much for joining. We are, well, on schedule basically. So thank you. Any questions before we end the call? Questions, anyone? Okay, so I'll share the recording in the Microsoft group for those that weren't able to join live. So yeah, thanks again. Enjoy the rest of your day.
Yeah, thank you very much, Blessing, for the class. Thank you.
Thank you very much.
Awesome. You're welcome.